Welcome to qnawire.
Schematic diagram of the spook's wheel. Now let us write the relation for angular velocity omega of the spooked wheel. That is, v is equal to minus twice r multiplied by omega. So omega will be minus v upon twice r. That is v upon twice r c w. V is the chord speed, R is the radius of the spooked wheel, and W is the angular speed of the spooked wheel. Now the angular velocity vector can be calculated using the right hand rule, that is omega. Okay, so we have omega is V minus V upon twice R multiplied by K. So since the spooked wheel rolls without spilling occurs, so absolute velocity of point C is equal to 0. So velocity of point C is 0. Now the positive vector of point A with respect to point C is negative OA I plus OC J. I is the vector in I direction and J is the unit vector in the Y direction. O is the distance between point O and point A, and OC is the distance between O and point C. So substituting the values of OA, that is minus R, plus OJ is RJ. Now the relative velocity at point P with respect to point C is omega RAC. So omega is minus V upon twice R K multiplied by minus Ri plus Rj, that is V upon 2 Ki minus V upon 2 Kj. So from this we'll get 0.5 V multiplied by I plus J. So the velocity at point A is Vc plus Vac. Now Vc is 0 and V is 0.5 V I plus J. That is V upon 2 I plus J. Therefore, velocity of point A is V upon 2 I plus J. Now the position vector of point B with respect to C is OBI plus OCJ. So we have OB is R plus RJ. Now the relative velocity at point B with respect to C is omega R BC. Omega is minus V twice R K multiplied by Ri plus Rj. From this, velocity at point B with respect to C will be 0.5 I minus J. Now the velocity at point B is Vc plus VBC. 0 plus 0.5 I minus J, that is equal to point 5, that is v upon, we have point 5 v, so v upon 2 I minus j. Therefore, velocity of point B is v upon 2 I minus